Hello everyone. I hope that you all are doing well. So in previous video, we understood about the list data structure and the implementation of it is an array and then list and linked list. Then there are different classes available in a ASP.NET, sorted list and doubly linked list and all. So let's go ahead with our next data structure. But before that, let's visit documentation of ASP.NET. So basically, when you visit this system.collection and you're able to see there is an array list, a bit array is available. So this is a kind of a list. Indexing is available. Then all this data structure we will cover. And then there is a sorted list. So these are some implementations of a list data structure in ASP.NET. And you just visit this particular documentation by Microsoft and you just see all the examples are mentioned. So if you want to visit the array list, so there is an array list. It provides you the definition, example, remarks, and different constructor, like what are the available methods are there, extension methods. Is it a thread safe or not? How you will implement it into a multi-threaded scenarios and all these things are mentioned. So go with it. Now let's start with the next data structure, and that is nothing but a stack. So stack obviously uh, is a data structure where we can see that it's a last in, first out. So if you can see this animated GIF image, so you can see that there is a stack and we are inserting, and there is a one more indicator is there. That is nothing but a P. So stack is a data structure implemented in a .NET framework in a two ways. Simple stack in a system collection namespace and a stack as a generic data structure in a system.collections. Generic namespace, the principle of stack structure operation is last in, first out. The last element entered will be the first out. Now you will just wonder that where we will use this kind of a data structure in a real development. So lots of examples are there. So one more example is like when you click a back button in your browser. This is the again good example. The stack functionality is implemented there. So as you visit a web page, it will add it to the stack and is your browse in your browser history. And when you press the back button, it pops the most recent item. Okay, when you press the back button, whatever the most recent page available in the stack, that will that atom of the stack redirects to the user. Okay, so you might be thinking that what are the different use and that you would not use much uh, of stack and but in fact the people really use a stack all over. Okay, it is internally available but we don't recognize that it's a stack. So whenever you need such kinds of a requirement in your product development, that you want to maintain the history or you want to maintain the kind of a latest information, latest data, latest caching, so you can implement that things in a stack. Similarly, there are some kind of limitations also that we will understand. Let's move ahead. Now, what are the operations we can perform on a stack? Obviously, push, pop, and one more is a peek. If you can see in this GIF, you can see that there is a peek, which is the counter, which is denoting the current value or current element of this. So it's an abstract data type initially, and which implements the principle that is the last in, first out, and is represented by the collection of elements that has a three main operations. First one is the push. It means inserting the element into the stack to the top, and pop is the operation which removes or fetch the data or element from the top of the stack. And the peak is obviously, it indicates always the top. And stacks commonly used to manage the data collections where insertion and removal order is important. Now, where to use whenever you want to maintain the order in such a way that if you are putting something in this data structure, you want to, the lastly putted data, you want to fetch first. So such kind of ordering is important in your product development, then you can go ahead with the stack. The most recent item added, the first to be removed. Think of it like a stack of dishes, and you can add on remove the dishes from the tap and extract. So there is one example. So in context of C Sharp or C hash, we can implement a stack data structure using the generic dot stack. Um, and the T is nothing but a type of element you want to create this. If you want to create a stack of type string or integer or any kind of a data structure. So this class provides push, pop, and peek methods which are already available. You just have to create an object of that class, and then you can call the related methods. So as you can see in this example, we can create a stack of an integer using stack int. Then we are pushing integers 1, 2, 3 onto the stack using the push method. Then we use the peek method to see which is the top element without removing it. We don't want to remove it. If you want to remove, then there is a pop method. But if you want to only check which is the element or which atom is available at the top, then you can use the peek method. So we then use the pop method to remove and retrieve the elements from the stack. And after highlighting two elements, we peek again to see the new top of the elements, which is the latest one and all. So you can go ahead with it. Now, what are the stack applications? Understood. What do you mean by stack? How to implement it in a ASP.NET or .NET framework? But where to use it? So obviously there are lots of uses of a stack. Stacks are indeed used in a scenarios where the order of the insertion we want, like this, nothing but a last in and first out. So obviously undo redo operations where you want to perform that uh, recently perform action should be undo. So you can use the stack in that case. Then there is a browser history. As we mentioned, there is a back button, and if you want to go ahead and fetch the latest page which you recently visited, then there is a stack we can use. Then next one is the call stack in a programming. So in a React or in a component based development, sorry. So basically we are calling the function in the form of a stack. Okay, so internal functions are there. So when a function is called in a programming, it's pushed onto the stack. And once the function completes, it's popped from the stack. So actual execution of such kinds of functions, it is by means of a stack. Okay. Then there are the different uses like state management in a front end frameworks and handling the middleware in a back end framework. So middleware obviously it get executed between your front end and back end. It's kind of a raw idea about, let's consider it's a middle available between the front end and back end code, and we call it as a middle. So it is always executed in the form of stack. If you want to perform some intercepting operations between the flow, then they always executed in the form of a stack. So these examples are nothing but a highlights how the stack are integral to manage the order, execute the flow, and the memory in a software development and managing various aspects of web applications. From user navigation to the state management and asynchronous processing. Still, if you want to access few more applications where to use and how to use Stack, there is a one good blog available on the Stack Overflow. You can click on this link and visit that particular. Now let's go ahead with, obviously in our ASP.NET framework, there is a class and there is a stack named class and stack named enumerate. Now, what are the difference? Obviously, it's so basic, like they are basically functioning or working on the stack concept, but they serve different purpose. So obviously, stack is nothing but a collection designed to represent in a last in a first out fashion, and it is a part of a system.collection namespace. What is the use? It's used to store and manage the collection object where the order is maintained, LIFO. Sorry, LIFO. And common methods includes push, pop, and fix, and contain method is also available. Now, enumerator is nothing but iterate over the stack. So we want a iterator. Okay, so whenever we are uh, working with a huge number of data, we normally consider there's an array, then we use for loop and looping structures are there, then for each loops are there. So to iterate through the stack, we have a separate enumerator and it's called as the iterator, and it's nested type within the stack class. And the enumerator allows you to traverse elements of the stack without modifying the collection. It's only visit, it's only fetch the data. Okay, it doesn't allow you to modify the value of a stack or a data. It implements the IEnumerator interface. So I hope these two classes are clear to you. And now, what are the scenarios when you should not use the stack as a data structure? So avoid using stacks when your application requires some kind of a random access, because obviously the ordering is confirmed, fixed in a stack. So that's why if you want a random access, then obviously it is not useful. Then persistent storage, then handling the large data sets, and maintaining order of the data. Bidirectional traversing is there from first to last and last to first. If you can able to traverse from anywhere to anywhere, then obviously it is not a best data structure. Or multi-threaded access, because order we want to maintain, so we can't allow the multi-threading. It should be thread set, or you can use a concurrent group. Okay, and then if such cases you want, then you can go ahead with the list, queues, or linked list, tree, or hash table, and etc. So while stack is a powerful data structure for specific use cases, it may not be suitable for all scenarios in a product development. So what are the problems? Stack only allows the access to the most recent and added data. So if you need the access or modify the element in the middle, then any other part of the collection, the stack is not a suitable in that case. Next, then persistent storage, what exactly it is? The problem is stack are transient and typically used for temporary storage. Now, one more thing I want to mention here is queue and stack, these data structures are used for the temporary storage. It's not for the long-term and long-run storage data structures. So if you are doing something operation, if you want to put that intermediate result somewhere, then you can go ahead with the stack. And again, that intermediate result, if you want to fetch it in order, last in, first out, then you can go ahead with the stack. So again, it's a temporary storage during the execution of an algorithm. They are not suitable for the scenarios where data needs to be stored persistently. So use database files, or what is the solution then? Alternative is nothing but you can go ahead with the database file storage or persistent collections like list or dictionary. Now handling the large data set. Now what is the problem with the stack? The stacks are generally not ideal or useful for handling the large data set because they can lead to the stack overflow. Now there are some certain limits given to the length or storage, and if you're trying to add huge amount of data, so there will be a stack overflow if the recursion or the number of the elements grow too large. Now, what is the alternative for it? So use the iterative methods with other data structures. Then complex data manipulation. Obviously, the problem with the stack is that offers the limited operations. Only the pick, pop, and push operations are there. So less suitable for the complex data like manipulating, sorting is not there, searching and maintaining the order of the data, which is not available. So then alternative is nothing but you can go ahead with the sorted list or hash set. Bidirectional is obviously the order we have to maintain. Now concurrent access in multi-threaded environment, managing the stack can be the complex and error prone without proper synchronization. So alternative is you can, as I mentioned you, that you can use the concurrent collections like concurrent stack and concurrent queue or other thread safe collections provided in a ASP.NET. These are some limitations where we should not use the stack. So I hope the stack is little bit clear. Let's visit the documentation about stack, where we can see the example as well. So here it is. It created one stack. We pushed some data in it. Then we are trying to count. We are trying to fetch the data. Then we are trying to fetch the values. Okay. We are using the for each here, as you can use the iterator as well. Now, what is the remarks? The capacity of a stack in a number of elements the stack can hold. As the elements are added to the stack, the capacity will automatically increase required through the reallocation. Now, again, this capacity also limited, as we mentioned, the drawback or where not to use the stack. So this capacity is limited. So if you have a huge amount of or large amount of data, so you cannot use the stack. So for new development, obviously, instead of recommending this is that maybe not a concurrent one. So you can go ahead with this documentation. So it's created with the generic one. The previous one was as you can see here. So instead we recommended two generic classes are available. So they mentioned that's okay, rather than using this one, you can go ahead with this documentation. So there is a toArray method is used to create the array from the stack, and there is a different constructors are available. So you can see created one stack with the generic data structures. And again, use the concurrent and concurrent queue types when you need to access the collection from the multiple threads. Okay. Now, stacks queues are useful for the temporary storage information, and that is when you might want to discard the elements after retrieving the value. So this kind of a data structures like stacks and queues are used for the temporary storage, and once you fetched it, you can discard it from that particular data structure. So if this is the scenario, then you can go ahead. Yeah, we will understand the queue in our next few slides. So common use of a system collection generic stack is preserve variable states during the call of other procedures. So this is the intermediate use of a stack. The capacity is whatever the value available, that is nothing but a capacity, and capacity will automatically increase if reallocation is required, if more data has been inserted, but there are still limits. Count is less than the capacity of the stack. So push is O of one operation. What is the complexity of it? And so these are some best case and worst case scenarios are there, and it accepts the nulls. There are available constructor properties and different methods are there. Interfaces, extension methods. So you can visit it. Now next is thread safety. Obviously it is not. You have to use the concurrent collection. And here we done with the stack. Now let's go ahead with our next data structure, and that is nothing but the partner stack queue. Now, queue is nothing but a data structure implemented in .NET framework in two ways, that simple queue in a system.collection namespace and in a generic. Okay. Now, queue having the two ends, okay, front and rear. And from one end, it should be inserted, and another end, it should be fetch, or it should be deleted. So let's go ahead. What are the operations of a queue? So there is a EQ and DQ. Okay, and you can see the peak also. So queue's data structure is obviously implemented with the principle first in, first out, which means the elements in elements that has been in the queue, the longest is the first to be removed. Okay, first inserted, first removed. So this, if you want this kind of a ordering, then you can go ahead with the queue. And EQ is the one operation. This operation adds the elements to the end of the queue, and DQ is nothing but a, this is the operation, removes the element from the beginning of the queue. Seek is nothing but it returns the oldest elements that is at the start of the queue, but does not remove it from the queue. It only reads that particular element available over there. In addition to those fundamental operation, queues often also provided methods for checking whether the queue is empty or not, and for inspecting the elements in front without removing it, commonly known as a peek or a front. So we covered that operation here in this bullet. So in other words, it works like a real queue of a people waiting in the line. So where whoever enters the queue first, that will be served first. What are the applications? Task scheduling, job management, then BFS algorithm, then common variations for queues includes the priority queues, double queues, and circular queues, each with their own specific use cases and the variations in a behavior. So is in this way we implement the queue data structure in a ASP.NET with the help of a queue generic class. And there is a enqueue method available for the adding the data in a queue, and there's a dequeue method available for fetching the data. So in the code mentioned here, queue is nothing but a queue of type integer called myQueue to store the integers, and then we use the EQ method to add the elements to the end of the queue, and we then using the while loop, okay, repeatedly to dequeue the elements using the dequeue, and the elements will be removed in the process FIFO, first in first out, and you can also use other methods provided by the queue class, generic queue class, such as a peek to view the front elements without removing it, and count to check the number of elements in the queue. So we are using the while loop here. Let's go ahead. Now this class implements the generic queue as a circular array, and objects stored in a queue are inserted at one end and removed from the other end. The dequeue and the stacks are useful. We already covered this particular point. Use concurrent queue. This is also we covered. The capacity of a queue is nothing but a number of elements available in the queue, and the elements are added to the queue. The capacity is automatically increased as required. So by allocating the internal array. So the capacity can be decreased by calling the trim access. So it accepts a null as a valid value for the reference types and allow the duplicates. So that is in the set, the element should be unique and all. So if you want to access the information in the same order that is stored in the collection, then obviously you can go ahead with the queue. And if you need to access the information in reverse order, then you can go ahead with the back. So here is the end of a stack and queue. In the next video, we will start with some advanced data structures. So hope you will understand. If you have any questions or queries, we will try to resolve it in a Q&A section. Thank you so much.